Yeah, no problem.
Okay. Good morning, dear participants and esteemed speaker for the session, Dr. Jagdish, Professor, Department of Mechanical Engineering, NIT, Raipur. On behalf of Department of Mechanical Engineering, BNMIT, I heartily welcome all of you for today's first session. Now I would like to introduce our session speaker, Dr. Jagdish sir. Sir holds a PhD degree in mechanical engineering with specialization in manufacturing engineering from National Institute of Technology, Silchar, and post-graduation in product design and development from NIT Warangal, India. He has over 3 years of industrial experience in the field of design and analysis and 7 years of teaching and research experience. Sir is presently working in Mechanical Engineering Department at National Institute of Technology, Raipur since 2018. His research areas are machining, surface modification and texturing, 3D printing, and design. Along with this, Sir also holds expertise in composite machining, decision-making tools, and thermal systems, analysis of thermal systems. Sir has supervised around 10 MTech students, and currently there are 3 ongoing students. And presently, Sir is guiding 5 PhD scholars. And along with this, Sir has also been awarded with many awards. To mention a few, Sir holds a gold medal from Institute of Engineers in 2016 for his research paper. And for his outstanding research contributions, Sir has been awarded for his been awarded with Best Innovative Paper by Springer in 2014. Sir has also received awards from Infotech Enterprises Limited, Hyderabad, and the same institute. Uh, the name is the Pat on Back Award, along with Team of the Month Award. Along with this, Sir has published over 25 research papers, and Sir has authored 4 textbooks and 10 book chapters, and most of them are being published by Springer Publishers. Currently, Sir is a reviewer of various manufacturing and optimization related Sci-Index journals, and is a life member of professional bodies like Associate Member of Institute of Engineers India and member of American Society of Mechanical Engineers, which is commonly referred as ASME. I once again welcome you for this session, sir, and I would like to now hand over the session to you. Thank you.
Thank you, Mr. Hemanji, for your kind introduction about me. First of all, am I audible, right?
Yes, sir.
And also thanks to your entire team and as well as institution, BNMIT Bengaluru, for allowing me this, this on this big platform of FDP, which is on artificial intelligence and machine learning for mechanical engineers. As such, special thanks to uh, Mr. Hemanji and as well as his organizing team for selecting a very such an important topic, which definitely needs for the today scenario. As we all know, we have come across since from 2 years we are facing the COVID-related activities or maybe problems. So in that case, the topic of artificial intelligence and machine learning plays very important role. In addition to that, through my slides, what I meant to say is I want to share my knowledge in the field of soft computing techniques and its applications in manufacturing area. And once again, I thanks to the BNMIT and its teams for organizing this wonderful. And also, I thanks to all the participants who have participated in this 5 days workshop. So with this now, I'll start my presentation through sharing my screen. I hope my first slide is visible to all of you.
Yes, sir.
So, once again, very good morning to all the participants and other members of the BNMIT. And today the discussion will be on the application of soft computing techniques in manufacturing processes. So as I belongs to a manufacturing guy, so I always look the aspects of the manufacturing systems, and one aspect is the application of the soft computing techniques in a manufacturing process. So today I'll discuss about what are the issues we normally faces and the challenges we come across when the implementation of the soft computing techniques in manufacturing areas or specifically manufacturing processes. So this will be the outline of my today's presentation. The coming around 1.5 hours or 2 hours, I'll be discussing on these topics. So I'll show you first my research team and the research areas where I'm working in the different areas. Then I start about some basic aspects of soft computing technique, because you may all know about this particular soft computing techniques, and I hope the previous since from 4 days you are maybe listening many experts talk. They might have already been explained about the soft computing and all. And then I'll start with some background of our manufacturing or the machining processes, and then coming towards modeling issues with respect to manufacturing systems. So what kind of the modelings and issues we come across when we model the real manufacturing systems. Basically, my talk will be restricted towards the process parameter modeling rather than the system modeling. Then the case study, I'll show you how we have done the modeling and optimization of a green manufacturing process here. So that is a new concept, and using the integrated soft computing technique that is based on the Taguchi combined with the fuzzy logic. So then I'll also share some of the directions of the future scope in the particularly the soft computing area and other aligned areas. So this is my research team and the areas of research where I'm currently working. Under my supervision, there are total 5 PhD scholars are working, and in addition to that, the MTech scholars. And all these are working in different areas of zones. Someone is working in the areas of the manufacturing, purely manufacturing, and some is working on nature-inspired surface texturing, and some are working in thermal systems, and some of them are working in the CAD area, and some of them are working as additive manufacturing, and machining, optimization, green composites, expert systems, and so on. So before starting, we should always go for some quote. A great scientist, Charles Edward, he has given a quote that is a very famous quote, that is that whenever we do some modelings, or whenever we go for models, or maybe optimization model, or maybe any models, definitely all the models are maybe wrong. We think that the models what we develop, they are definitely wrong, but doesn't mean that the kind of models we develop always it will be wrong. There may be something usefulness of that models definitely in the real life. So with this, we'll start our presentation. So starting with, as I told that the main title is the soft computing. As we all know, the soft computing is basically derived by great Professor Lochte Jade. He has introduced the concept of soft computing, specifically a fuzzy logic, into the field. And what he defined basically the soft computing is such a field of a field where maybe he has defined in different way. That means a soft computing is basically a field of computer science wherein the use of inexact solution of a problem which has a known method to compute an exact solution. So definitely this definition will hold in the real conditions as well, because we come across various kinds of inexact solutions, right, or unknown the problems. We don't know anything about the basic background of any problems. So such problems is very difficult to solve by certain mathematical conditions or mathematical equations. In such conditions, there is a method or there are some technique, there are some ways through which we can at least, inexact solutions for the problems we can, try to extract, or we'll try to, get the solutions for unknown problems also. So if I talk about again manufacturing system, the manufacturing system is if it is a new manufacturing systems, so definitely we don't know what is its performance under different parameter conditions. So that is the unknown method, right, or unknown conditions. For those unknown conditions, one can predict or one can solve an approximate solution for that particular problems. Likewise, the soft computing area, soft computing field is also such field wherein use of an exact solution of the problem which has a unknown method to compute an exact solution. So the aim of this particular techniques of soft computing is also says same thing. So it uses an imprecision, uncertainty, partial truth, and approximation. That is the beauty of this particular soft computing, because as such, if you compare the other techniques of optimization, either it may be evolutionary algorithm, either it may be decision making tools like multi-criteria decision making tools. Okay, all these may not consider the aspects of imprecision, uncertainty, and partial truth and approximation. As such, the soft computing is also approximation tool, wherein you get an approximate solution for a problem. So because these terminologies of imprecision, uncertainty, and partial truth and approximation exist in the real problems, and all these parameters will take as an input for this soft computing techniques. So that means any optimization technique, if I talk about, where we need some input, that may be in terms of quantitative data. In most of the cases, we use some quantitative data to modeling the system. But whereas in some circumstances, we may come across in the real field, wherein you have the imprecision data. That means there is no precise data for that, right? Or there is uncertainty. Uncertainties exist in our daily life. Even in our human life, we come across various uncertainty. We don't know tomorrow what will happen with us, with our body, right? There is uncertainty. Definitely there is uncertainty. So, but under the uncertainty conditions, we at least predict what will be the tomorrow, right? What could be the tomorrow, or what will be the tomorrow? Okay, so that kind of predictions we predict by using these techniques. And there is a partial truth. Definitely, there is no exact solution. That definitely the input in condition that this may behave in this manner only, or this manner only, or X manner, or Y manner, or Z manner. So that means that there is a partial truth exists. All these circumstances, our soft computing techniques may help you to get the closeness results or closeness values of a problem. Based on this closeness resemblance with the and with the humans, we take a final decision that a particular system or the particular process is in a good condition, or maybe working in a well conditions, or working in a perfect conditions as it is designed, or as it is thought for designing purpose. And also these models, okay, and the solutions to the real problems which are not modeled are too difficult by mathematically. Sometimes we may come across in our real practices that some of the problems we cannot handle, or we cannot approximately solve by using some other techniques that can also be modeled by using this approximate technique of soft computing. So then what basically soft computing consists so far? So it consists of three major zones. One is called neural network zone, fuzzy system zone, and the GA zone. You already know about all this concept of neural network, fuzzy systems, genetic algorithm. Initially, the genetic algorithm is the first invention. Thereafter, neural network and fuzzy systems is simultaneously has been arrived into the market. So all these neural network, fuzzy system, and genetic algorithm is being used for approximate solutions for real problems. It may, if I talk about the fuzzy systems, the fuzzy system is always working on the principle of the imprecision or for knowledge representation via fuzzy rules. We know that for fuzzy systems, by using a fuzzy system, if one want to model a particular system, then we need imprecision data, or maybe we develop the knowledge base. So based on the knowledge base of that system, via if-then rules, we will say that the performance of that system is well or good or better under the circumstances of the what it is designed so far. Similarly, neural network works on the principle of learning and adaptations based on the output of the system or based on the learning from the system and then adoption of that system parameters or maybe conditions, so that neural network would be used for modeling the problems of the real problems. Probabilistic reasoning, definitely there is uncertainty conditions is to be is considered in this kind of reasoning of the problems, and evolutionary computing most probably we basically use in optimization side. So when we talk about a soft computing approach, this soft computing approach in the real practices has two conditions, right? One is called the mathematical world. That means where we have very hard data. That means we have the quantitative data. And this hard data will be gathered by using various quantitative methods. And we have a bivalent reasoning. So that means we have only limited reasons to get that particular behavior of the system. If I talk about again manufacturing system, the manufacturing systems, we have quantitative data as well as the qualitative data. So quantitative data are those data which we extract from the measuring, or we are extracting from the equations. Say for example, MRR, metal removal rate, we derived by using some equations, or will get determined by using some equation. That is what we call as a quantitative data, which can be easily measurable or which can be determined by using equations. So that comes under all those conditions will comes under the mathematical world. In addition to the mathematical world, there is another area where we don't have a hard data, or we don't have a quantitative methods to extract the data. That is we call as linguistic world, wherein we have a imprecise or uncertainty data, like it may be we call as a soft data. Okay, and interpretation is very much is required in this case, because error in the interpretation results in the output will be an error. Okay, so therefore the interpretation of these soft data is much essential in the case of linguistic world, wherein you have the low, medium and high. Okay, this kind of low temperature, high temperature, medium temperature, okay, and very high, very good, bad and poor. These kind of data we call as a linguistic world, where you have this kind of data. In that case, the interpretation of this data plays very important role. So insignificance or the error of interpretation of this low, medium and high results in output error definitely. Or you may get the output, because as this is a black box where you will input something, right? It may give output, but this output may have we don't know whether that output is in a good, or it may be it is acceptable in conditions as per our requirement. Then there is a qualitative methods, and there are multi-valent reasonings. Yeah, definitely there are a possibility of reasons to get the direction of output errors in the case of linguistic world. That means there may be many reasons you may find to get the linguistic variable to be disturbed. So as such, that means the soft computing can be used in the mathematical world or in the linguistic variable or world, where one can implement these particular techniques to handle the conditions of the real problems. Move on to the soft computing applications. So whether the soft computing techniques or the methods have already been implemented in the real practices? Yes, there are plenty of applications we find wherein these soft computing techniques have been implemented in various sectors. Let us talk about a heavy industry. In the heavy industry, these soft computing techniques have already been implemented for controlling of the robotic arms, right? The movement of the robot arm is controlled by our soft computing. It might be a neural network, it might be a fuzzy logic, it might be a something reasoning based methods. So, but the implementation of these soft computing techniques is already been there in the industries. Like humanoid robot is the again the action or the control of the humanoid robots are controlled by this kind of techniques of soft computing. Then, if I talk about the home appliances we already use in our daily lives, like washing machines, ACs, refrigerator, cameras, all these machines have, you know, digitized, okay, or optimized by using these soft computing techniques. So we may come across these operating of these machines are based on the fuzzy logic, right? So that means what I'm trying to saying is the application of this soft computing techniques is well implemented in their daily lives. If I talk about the manufacturing industries like automotives, so where the travel speed of the vehicle is estimated by using a particular what is called a soft computing technique, or one can predict that if a condition of x1, x2, x3, then what will be the speed of the the vehicle. So that kind of the prediction or maybe modeling of the system is done already in by industries. Sleep warning systems, yes, we know normally sleep mode and all we keep our AC and fridge. So there the sleep mode is handled by using or activate or deactivate based on the soft computing technique. So move on to the real core manufacturing and machining systems. These days the researchers have already started for implementation of the soft computing techniques in the field of machining processes. Because the machining process is also one kind of system that is having some kind of depends on some of the parameters, and the performance of that machining system is only quantified by what quality characteristic is produced by those machining systems. So hence need of a modeling is required. Again, the modeling of these manufacturing systems is again contains some uncertainty or sometimes imprecise. Sometimes we may set the value of the input conditions for these manufacturing systems like low pressure, high pressure, and the medium pressure, something like that. So in such conditions, there is a possibility of implementation of the soft computing, or there is a need of soft computing to be used in such manufacturing systems also. Modeling of complex production systems and optimization of the process parameter, prediction of the parameters is one such possibility of application of the soft computing techniques in the manufacturing zone. In addition to the above industries, in education also we can use this particular concept of soft computing to handle the evaluation of the performance of the different parameters of the education systems. Again, this education is again a system, that means a black box. There, the performance of this system is handled by various parameters, and so that you will results y1 and y2. That means the performance parameters of that system. So that means what I'm trying to saying is that so the soft computing is basically is used in various conditions depending upon the need of the applications. If you have the input conditions like imprecision, uncertainty, and some approximation data, so one can use of the soft computing techniques to make to study the performance of the systems. So my talk will be restricted towards the manufacturing and the machining process, modeling and its performance study. So when we talk about the machining process, because I given a briefly about the soft computing because you know already about that. That's why I given very brief about the soft computing. So I'm mainly restrict my talk will be on the manufacturing area. Right? In the manufacturing process, when we talk about or when we define the manufacturing systems, we all know that it is basically a collection of integrated equipments, right? So manufacturing systems or manufacturing process is collection of various integrated systems, equipments, right? Maybe conventional systems or non-conventional systems. Okay, so all these systems and the human, okay, so an operator, what we call as human, and whose the function is to generate the raw material into finished product. Okay, so that means here in our machining systems or manufacturing systems, we need an input is called as a raw material. That means the aim of this particular manufacturing system is conversion of raw material into finished goods. When we converting, we need various types of operating equipments such as machineries that may be include NC, non-NC, or advanced manufacturing systems. Various types of toolings we use for generating so. We use various types of energy power, source of energy to operate that machining system, and also we need a skilled operator to operate that such equipment or sophisticated equipment to convert a finished part. However, when we generate the finished part, there may be chances of getting the scrap as well, right? That means there is a definitely when there is a machining system, definitely it removes the material to get a desired shape. When we are removing the material, definitely there is an arises of scrap and the waste. So therefore, the word manufacturing is derived from the Latin word that is what manu and fax. Manu means manufacturing and fax made by a hand. Okay, so that means by using different kinds of machinery, tools, and the power and the operator, that systems will convert the raw material into finished product, and that finished product will be sent to the customer for utilization. But during this conversion of raw material into a finished product, so what basically this input or this transformation is required. Okay, that means transformation from raw material to finished products. We need three types of stages, okay, of the manufacturing systems. One is called as input, wherein we give input requirement of our machine or input requirement for our manufacturing systems. Input may be a man, that means the operator who handles that. Material, different types of materials may be conventional materials like maybe ferrous material, non-ferrous, polymer, okay. But as such, the machining systems may not be in the brittle materials, or maybe non-conductive materials may not do in conventional, non-conventional. But some of other systems, they may do the machining of those materials. Then different types of the machines, maybe conventional, non-conventional, and the drawings, which is required to convert the shapes. So these all the input will get transformed to the output. That means the final good and services by some transformation operations. You require some operations, material handling, recruitment, etc., process planning, and so on. That means there is a need of transformation systems, or transformations is inbuilt in the system that converts or that transforms the raw material into a finished product. So as such, when it is converting the raw material into the finished parts, there is a need of a modeling of the system, right? Because while conversion, this manufacturing systems behaves in a various way. One system and the variation of the different system is vary with the condition of the system. Some manufacturing systems vary in X way. Some conditions of the manufacturing system vary in a Y way, right? So move on to the classification of the machining systems of the manufacturing systems. I want to show how we classify our machining processes, maybe a traditional and non-traditional. Under traditional, there are various possibility of the machining systems are there. They are basically for cutting purpose, to cut the various types of shapes, like maybe our traditional like milling, planing, shaping, broaching, sawing, gear forming, gear generating. All these are conventional or traditional machining systems. But if I talk about the advantages and disadvantages, obviously each of the machining system has its own advantages and it's having its own disadvantages with respect to the application point of view. Non-conventional, there are plenty of non-conventional machining systems available for manufacturing systems or to manufacture the finished goods. In addition to non-conventional machining systems, there are advanced manufacturing systems also be used, like an additive manufacturing systems. Okay, and those will be used for in the special cases where we are adding the metal rather than the subtractive in nature. So come to the modeling issues. What kind of the modeling and issues we come across when we model our manufacturing systems? So as we all know that the machining system is basically consists of various types of possibilities or the criterias under which these machining systems will work. Because this machining system contains the various types of category, as already shown in the previous slide. That means maybe a conventional machining system or non-conventional machining systems. All this conventional system and its performance is depends on the input parameters, right? So one want to study the performance of this particular system. So we need or it depends on various input characteristics, like maybe we use the different types of the workpieces to machine the finished goods. We use different types of tools to to remove the materials from the workpiece. We use different types of energies sources to operate that machine, and we use different types of process to carry out to start from raw metal to what is called as a finished product. As such, the variation of these all input conditions to the machining systems results in maybe output characteristics, and this output characteristics will have the effect on the performance, because the performance of these machining systems is measured based on the output quality characteristics produced by those machinery systems or the manufacturing systems. So if the variation of the input or error in the input results in the quality, maybe product quality, production cost, that means the quality of the product may be reduced, the cost of the production will be also very high. Then we came across the lesser removal of material, noise also will generate, the heat will generate during the machining system, and the process time consumed by that system is very high, and the tool wear it is also very high. So all these aspects of manufacturing will make our system to be incapable, or we say that our system is not in a good condition to give output characteristics that makes our system to be perfect, or that makes our system to be acceptable in conditions during the system. So I request the participants to mute your mic, because I'm getting some disturbance in between. Yeah, thank you. So once when we get the manufacturing aspects, in error, so it's all depends on what is called as the input conditions and the machining conditions. So another aspect is the environment. Yes, that is the machining conditions. So because a different environment, the behavior of the machining systems is differ. Say one machining conditions may work in a worse environment, one machining system work in another worst environment. So depending upon the environment of the working condition also results the error in the output conditions. All these issues we came across while the performing or while measuring the performance of these manufacturing systems. So hence there is a need, or the challenges is how we can model these systems effectively, so that the performance characteristics produced by these systems get an appropriate or acceptable in conditions, thereby which increase or directly or indirectly increase the performance and efficiency of our such system. So hence there is a need of some parametric modeling and optimization of manufacturing system is so essential. So as you can see this, if I consider the manufacturing system in a black box, isn't it? So this is a system. It contains any system, maybe conventional system, or a non-conventional system. Okay, non-conventional system. So whatever it may be, the machining systems, if you vary, it depends on various factors like x1, x2, x3, and xn. And when you send the input, or when you give the input of a different workpiece, different tools, different energy, different process, so results in some y1, y2, and yj and yn. So that means this y1, y2, y3, and ym is having depends on the input, because if the factors is vary, this y condition or the output is also vary. So that means, and this all output is depends on the factor and uncontrollable variable. Sometime the designer will do the mistake that they may not consider some of the uncontrollable variables such as environmental conditions, noise, and etc. during the modeling, because that also results the effect on the output quality characteristics of the machining systems, thereby reduce its performance or the efficiency of the system. So therefore, the modeling of these systems is essential. As such, as it is a black box, one can give any input, it may give some output. So therefore, condition of giving the input is very much important, and what conditions you want to behave your system, that depends on x and the z parameters only. So therefore, many researchers have used the various types of technique or the methods to control these uncontrollable variables and the factors as well. One such is the statistical methods. They might have used the statistical methods to control this kind of uncontrollable, like maybe a Taguchi. Well-known method is the Taguchi method, where we control the SN ratio, that means noise conditions of the machining environment, to consider the noise factor, to modeling of the system is carried out by the various researchers. And some of the design of experimentation techniques to reduce the number of experimentation, thereby it reduces the production cost as well as the lead time, that is the manufacturing time. There are various types of the statistical methods, like surface response methodology might have been used by various researchers for doing so of perfect modeling. ANOVA is a well-known, Gray relation analysis, regression. All these statistical methods, people or the researchers have already been tried, but there are lacuna or the drawbacks or the demerits of these statistical methods also exist in our modeling of manufacturing systems. What are those? Some of the challenges are these manufacturing systems, or the performance of the manufacturing systems, contains multiple output characteristics, like say for example MRR, heat, process time, tool wear. There are multiple criteria. One cannot handle this by using a statistical method, right? Another challenging is all these quality characteristics and the input conditions are uncertainty is there. Uncertainty due to environment, uncertainty due to input conditions, and chances of input conditions are imprecise. A designer don't know under what condition, under X condition, my system, how it behaves of Y values, or how this Y values will be given by the system. So that means there is an uncertainty, there is a imprecision, there is a possibility of uncertainty is existed in the system. So in order to handle such issues of multi-responses and non-linear in nature, that is one of the biggest problem, because all these quality characteristics, they behaves in non-linear mode. Okay, so the metal removal rate for a particular conventional system for a particular input of x1, x2, x3, it is may behave different. Or if you add one more parameter of x3, then metal behavior is maybe different, because the effect of that x3 on the machining system may vary, and that results in effect on the MRR. That means there is a non-linearity in the system that need to be considered into account while modeling of these systems. So all these conditions can be handled by a soft computing technique. Maybe this all these issues just can also be handled by other techniques, but so as my talk is restricted towards the soft computing, so I'm trying to saying or making my model towards the soft computing area. So as such, these issues can be handled or can be overcome by using soft computing. There are plenty of soft computing methods. They are, fuzzy set theory, fuzzy interference system, AMFISH, and expert systems. So all are based on the fuzzy logic concept. And in our study, we will show you that how the decision support system or the expert system will be utilized for modeling the manufacturing systems. So when my talk will be restricted towards the expert systems, so let's talk about what basically expert system is concerned, right? So when we talk about expert system is a one kind of special skill or the knowledge representing the mastery of a particular subject. Obviously, yes. So when an expert, when we say it is maybe the terminology is related to the mastery of a particular knowledge of a subject. Okay, the knowledge of that particular zone of an area. So if I relate this particular word with the manufacturing system, yes, whoever is working in the manufacturing areas, they have expertise in that what could be the the behavior of a particular X system or Y system. So and this expert system is also designed to solve the real problems in a particular domain that normally would be required a human expert, because without human intervention one cannot predict or one cannot judge or one cannot take the condition of input of a system for interpretation of the output results. So there are plenty of expert system for applications you may find in the real practices. The researchers have been already implemented. So what are the components of this expert system is having? It is having the acquisition facility, knowledge base is required. That means there is a base is required. Based on the base of knowledge, the system will able to predict the conditions of the future, right? Then interference engine, where it will convert the if-then rule for development, workspace, explanation facility, reasoning capability, and user interface. So all these components our expert system is able to having. So the architecture of the expert system is basically goes like this. So that means it is having a module called as knowledge acquisition module, wherein entire system knowledge will be stored. Say for example, if a system is there and you have know that x1 and there is x2 parameter, x3 parameter, and you have given and you know that y1, y2, y3 of that system. That means you have the knowledge base. That means you need to create the first knowledge base of that system. Based on the knowledge base of the systems, it will act and it will give another future value of the prediction. So that means knowledge base is essential in a expert system, and that knowledge base will be further transformed to interference engine, where the engine will perform the works to develop various if-then rule based on this if-then rule. So the system will give the prediction value. So then that explanatory interferences in the database, and this after the interference engine, and the user can use this particular expert system for making the decision. So how this interference engine will work? This interference engine will work having 3 steps. One is called, you need a crisp data. You might have the word of crisp data. Crisp data is basically normally what we get in the manufacturing system, that is maybe MRR value, RA value, okay, and so on. So maybe TWR value. All of these are scripts data, right? That means it is having in a value form. like MRR is maybe 20 mm³ per minute. Okay, RA is or 0.9 micrometer and so on. All these values are basically a CRISP inputs. So this CRISP inputs is getting transformed to linguistic variable first. That means that stage we call as a what is called fuzzifier or fuzzification. So fuzzification is a stage wherein the entire data is converted into what is called as a linguistic variable. Linguistic variable may be in a low, medium, or high, right? So good, very good, or poor, like that. That means that is nothing but stage number 1, where conversion of the CRISP value of the input conditions into fuzzification, because the fuzzy takes the linguistic variable rather than the CRISP values. Therefore, the need of fuzzification is essential here. Once the fuzzification is done, so that has to be transformed to the interference engine, where the various rules or the conditions will be developed. Under what condition? Condition number 1, condition number 2, condition number 3, and then what will be my MRR? What will be my RA? What will be my TWR? Like this. That means the conditions will be developed. Under those conditions, so your system will able to predict the condition, circumstances. Then once the if-then rule is developed, then again we need a CRISP value rather than the linguistic variable, because it is very hard to read the linguistic variables and very difficult to interpret the what is called linguistic variables to take the decision. So therefore, defuzzification system, or the third stage is defuzzification, will be carried out, wherein again the linguistic variables will converted into CRISP value. That CRISP value may be in terms of the quantitative data. Based on this quantitative data, one can decide, or one can take the decision that whether my MRR is satisfactory value, or whether further need to be improvement is required in the input condition. So this is just a construction of a fuzzy expert system, where the data preparation, interference methodology, defuzzification, linguistic variable, then membership function and the roles, then finally we do the optimization of that particular system. There are various applications we find the expert system, maybe agriculture, education, environmental management, sports, mechanical engineering, computer engineering, and medical domain, and many more you may find. So as such, my restriction will be again mechanical side, wherein I'll show you how the implementation of these expert systems can be done by in the manufacturing systems. So now I will discuss about our case study, where the implementation of this expert system in the green manufacturing systems or the green manufacturing process will be based on using of Taguchi combined with a fuzzy logic based expert system. So when we move on to the introduction about this topic, so when I say green manufacturing, definitely you people may be aware about this concept of green manufacturing, or may not be aware. So let me tell you first what basically green manufacturing is. Green manufacturing is basically a advanced manufacturing system, wherein it considers the both process and the material that are economically viable, and also results lesser environmental impact during the machining system. Then the question may come in your mind, then how our machining system is moving towards or falling in the category of the green manufacturing? Yes, of course, because we all know that the machining systems, whether it is a conventional or non-conventional, they produce, or they are major source of environmental pollution. They produce various types of wastages, maybe in the form of solid, maybe in the form of liquid, or maybe in the form of gaseous. If I talk about a EDM machine, solid may be in the form of chips, liquid may be in the form of dielectric, gaseous may be in the form of aerosol generation or emission generation. All kind of wastages will be generated. In the meantime, resulting of these wastages generates various types of occupational health and hazardous issues. Like say for example, gases is generating during the machining system by burning of the lubrications. That results are can enter into the body of the operator that may affect the health issues as related to the operator. So that is again a kind of environmental issues. And sometimes the entire machining zone itself is becomes a pollute, and that also is a one aspect of environmental conditions during the machining system. So that means what I'm trying to saying is that almost all the machining systems may be conventional or non-conventional or generates are the major source of environmental pollution, and that needs to be minimized. Then the questions comes that what kind of the pollutions we may get from the machining systems. There are basically the two performance characteristics we measure. We call as manufacturing aspects, another is the environmental aspects. Environmental aspects are those which are affect the environment of the machining. That may be process energy. Okay, that means the we measure the environment conditions in terms of measuring the process energy consumption by the system. If a system is consuming very lesser energy of and producing a very good manufacturing aspects, one can say that it is a green manufacturing system. Or that system has to exposure to lesser aerosols during the system. So then we say that that system is a well-known moving towards a concept of green manufacturing. Otherwise, it is a that parameter results in various environmental issues like slurry, mist, and chips, dust, noise, dielectric consumption, etc. There are many more parameters which comes under the category of the environmental aspects. So that means when we measure the performance of these systems of manufacturing systems, many of the authors have considered only manufacturing aspects so far, but they are missing the important parameters of the environmental into account during the study of the performance. And also the measuring performance of this machining system is also depends on the environmental parameters also. Okay, so without considering this environmental aspects, so one cannot say that the system is a green manufacturing system or that system is moving towards the green manufacturing technique. So therefore, the effect of the environmental aspects also will have the impact during its performance or during its quality characteristics of the manufacturing aspects. Again, these all manufacturing aspects plus the environmental aspects depends on input conditions. The improper or the error, the improper selection of these input conditions will result in output quality characteristics. So therefore, some of the challenges we faces in our green manufacturing system, that is a multiple responses. That means it is having a multiple outputs and under multiple conditions. So one has to take the decision that what condition of input we get or that machining system gave a better performance in such conditions. Highly complex and non-linear nature because the behavior of the parameters of the output may differ with respect to the input conditions, maybe operating conditions, maybe different material, different tools, energy and process. And also involves some uncertainty, that means vagueness in the data, that may be lower the better, higher the better, or nominal is the better. There is a vagueness in the system. And sometimes the imprecise and subjective data only, sometimes objective data also. So that means there is an uncertainty, imprecise is there, complex system, non-linear nature. All these circumstances of the challenges can handle by using a short computing technique. Why? Because it is an effective process of design and prediction purpose. It is a flexible in design, that means it is having a flexibility in making the decision. Also consider the level of uncertainty, like maybe lower the better, higher the better, nominal is the better, and also reduce the number of experimental work by using some statistical methods. So this is our decision making strategy, what we have made so far. in the combining of the Taguchi with the fuzzy logic. This is one of the new integrated technique we have developed so far. It works on the majorly 6 steps. The first step is the development of the knowledge base. Knowledge base generation is very important because as we know that the fuzzy logic expert system needs the knowledge base. So knowledge base is nothing but here we are creating the knowledge base via experimentation. And for experimentation, we have Taguchi design. Why we have used Taguchi design? To reduce the number of experimentation, depending upon the kind of input parameters and the level we have considered so far. So in generalize, if I talk about when you have a more number of input parameter in that level, number of experimentation will be definitely increase. Okay. So if you use a full factorial design. So in order to reduce this number of experimentation, we go for fraction factorial design, wherein one method is the Taguchi method. Okay, this Taguchi method is basically well-known method. I don't want to talk about much on this particular Taguchi method because you know very well about that. So the Taguchi method here is used for converting generating the database. Once the database is generated, it is in a normalized because we have the qualitative characteristic maybe our output responses may be different units. Okay, that means MRR may be in maybe mmQ per minute, RA surface roughness is micrometer, right? So all are in different units. So one the conversion of some mapping of the data, or maybe conversion of comparable sequence data. So we do some normalization system or normalization process. Once the normalization data is over, then it is entering into our main fuzzy logic system. So in that first step is the fuzzification, wherein conversion of crisp value into into linguistic variable, and by using membership function. So questions may come that what kind of membership function we basically use. So this is depends on the type of input parameter conditions and the need of accuracy level. There are plenty of membership functions are available. What basically membership function? Membership functions are nothing but it is just an method of mapping of the data, right? There are various membership functions and mapping of the input data in terms of membership grade, right? So here the y-axis will be membership grade and this is the input condition. So when you are mapping the input condition in terms of some functional, okay, some function of curve, and that that curve gives a membership grade. At what grade that input condition is. So that means maybe a L1 level, a L2 level, or L3 level, depending upon the type of levels or different type of levels considered for your input conditions. So there are various types of membership functions are there. One is called triangular membership function will be available. Then trapezoidal membership function is there. There are some called as Gaussian membership functions are there. So depending upon the application and the accuracy and smoothness of the requirement, we use a different type of membership function. So once the membership mapping of the data is done, that has been sent to the interference engine. One of the modification we have done in the case of interference engine in our strategy, our decision making strategy, is that normally in a fuzzy interference engine we use just to if the conversion of if-then rule, okay, if-then rule only. But most of the interference engine, specifically Mamdani method, most of the cases the Mamdani method will be used by the researchers. That is having some drawbacks or the limitations because there is no flexibility in developing the if-then rules. No more number of if-then rule will generates, and difficult to that increases the computational time of the system. To reduce these all aspects of Mamdani, we have used a Suguno-based Tagaki-Suguno-Kang fuzzy rules method to develop the if-then rules. In addition to that, the subtractive clustering technique we have added into this. This is the beauty what is the importance of adding the data clustering technique or subtractive clustering is because in the case of Mamdani model, so as I already told that there are limitations that number of rules will be more, okay, and inflexibility, okay, flexibility is not there, and computational time is more. So number of rules means again this affect the computational time. In order to overcome this such kind of limitations, we have used a subtractive clustering. This clustering technique will help you in defining the cluster centers and how many cluster centers is required to be sufficient for generating the if-then rules. Those many only it will be used further for if-then rule creation. Otherwise, the number of input parameters, if it is increases, number of if-then rule also increases. So one cannot model or those many number of if-then rules. Thereby, it increases the computational time. So, in order to reduce this concept of number of if-then rule, we have used subtractive clustering. What basically this clustering technique do is it will calculate a number of cluster centers is required. So how it will calculate? It will calculate based on the clusters it will be made by the database. So maybe a cluster number 1, cluster number 2, cluster number 3, cluster number 4. So and these clusters it will make depending upon the data or the input conditions, and it will distribute all this data into some number of clusters, and those cluster values are nearby density values that fall under that particular zone. That means a zone number low zone, medium zone, and the high zone it will generate, and based on the database it will generate some clusters, and that cluster is basically based on the density points of the value. So based on the density value, it will cluster center. It will make the clusters, and maybe say for example, if you have a 64 number of experimentation, your subtractive clustering method may give you only 15 cluster center is enough to predict the model performance of that particular system. No need to go for a 64 rules. Instead of that, you can only go for a 15 rules to generate the prediction. So that is handled by using a subtractive clustering here. So based on the subtractive clustering information, so we will develop our methodology will develop the if-then rules, and then it is again once the if-then rule is generated, then it is next process is the defuzzification, wherein conversion of linguistic variable into again crisp value. That crisp value we sometimes be referred as fuzzy performance grade or fuzzy relational grade. So this based on the fuzzy relational grade, we define the optimal conditions. In the case of optimization, when we use for prediction purpose, so we use directly the defuzzification values for making the prediction. In that case, the input condition will be input parameter. For optimization condition, input condition will be output responses. So if that model is giving adequate results, then yes, it will be considered. Otherwise, the data revising will be done, and this process will continue until your data is getting a optimal data. Then further ANOVA analysis we carried out. The reason behind of creating analyzing the ANOVA is because we get the data. Whenever we have a data, so need to be whether the data is behaving as per the statistical or not, statistical conditions or not. So to judge that, so one can use statistical methods to to validate that data whether that statistically significant or not. Then later the performance of the this model is carried out by using various tests. So coming to the experimental conditions, what we have used for our study, because we need to develop a database. For that we have used the abrasive water jet machining systems of machining of green composites. So as such, this system is a green manufacturing process. Sometimes we referred as the abrasive water jet machining system is a green manufacturing system. Why? Because there are plenty of advantages compared to other manufacturing systems of machining. That means one is it is a greater flexibility in cutting of different materials. Second one is it less environmental conditions or contamination. Sorry. And the third one is there is no fumes will be generated during the this machining system because we use water as a lubricant. And the fourth is less minimum force will act during the machining system, so that may result lesser damage of the workpiece. And the fifth one is it is not a thermal process; it is a where there is not much heat will be not generates. So that makes the heating of the components workpieces. So all these results in one can say that due to these advantages, this abrasive water-jet system is a green manufacturing system or environmental machining system or environmental conscious machining system. So as such, the material also we have used a green composites. Sometimes we referred as then green composites, where we use a natural fiber as a filament reinforcement materials, and the matrix is epoxy to machine these components. Okay, so as you see, these are the square drilling operations we have performed. The square profile we have cut it for a different operating conditions. The operating conditions we have used for our study is there are 5 input parameters we have used. That is what we call as a grain size, stand-up distance, pressure, mass flow rate, and the nozzle speed. And then some of the input conditions like the constant conditions of the system. And the three levels we have considered for our study. But the questions may come that why 3 levels? How we decide this number of parameters and number of levels in the manufacturing systems? It depends on various ways. It depends on the what is called the specification of the machining system. That means the designer who has developed this machining systems, he has maybe given the range of the operating conditions. Based on that, this is the first condition. Second condition is that very important. Based on the literatures, one can identify the major input parameters which are more essential to the system by using various methods. Normally, we use a fishbone diagram or Pareto analysis for selecting important parameters which more essential to the output quality characteristics. Then the levels is decided again based on the range of input conditions, and also this may be decided by using a pilot experimentation, because this level or the range of each of the input condition may differ for a different material, I would say, and that can be decided by using a different pilot experiments and see the output quality characteristic for the different range of input conditions. When there is a saturation in the input conditions or output condition is arrived, in such condition that range will be decided. Right? This is the method of deciding the number of levels. As such, we have done all these exercises before deciding these input conditions and the levels. So we arrived these input conditions and the ranges for our study. This is what based on the input conditions and that level we have performed applied the Taguchi method, and we have performed these many number of experimentation according to the Taguchi method. Now we have the experimental data, that means the database for our abrasive water-jet machining condition while machining of the green composites. So now the modeling steps for the optimization strategy. So that means this is a knowledge base. First step is a knowledge base. That means what we have created so far. And this is the falsification of the input data. That means where we have mapped the input conditions. But one more thing I want to highlight here is I am doing the optimization where we have considered the output quality characteristic as an input condition for the system. So then these are the membership grades. These grades will decide to what condition of this input variable is, right? So, and once the mapping is done, then fourth step is number of cluster data determination. That is one of the additional activity we have carried out in our study. that reduction or optimization of the number of rules in terms of number of centers. So our subtractive clustering center gave only 10 number of centers that are more feasible for prediction of entire zone of the input condition of a abrasive attached machining system on machining of green composites. That means no need to develop a 27 if-then rule, okay, to predict the output quality characteristic of the system. But here in this case, N10 is sufficient for making the decision. So based on the subtractive clustering, we have developed the rules, and then we have extracted the fuzzy performance grade or the fuzzy relational grade. Based on the relational grade, and we have seen that higher relational grade give the optimum condition for that system. So based on the FPC value, we obtain that 25th experiment will be the optimum experimentation for our study. But the question may comes in this stage also that sometime the optimal conditions may arrive in within the table matrix or maybe out of the boundary as well. So when the optimal condition is arrived to be out of the boundary, in that case, we can do the resetting of the system, or maybe we perform the confirmatory experimentation in such conditions to validate that results. Move on to the modeling steps for prediction strategy. As already told that instead of the optimization, we have done the prediction activity as well for prediction of each of the quality characteristics of the EWGM process. So for this, the fuzzification of the input condition have been carried out by using a triangular fuzzy function. As such, we have the three levels, L1, L2, L3. So therefore, we have used triangular function. One can use the Gaussian function also. Doesn't that only restrict to triangular function? One can use the Gaussian membership function as well. So here, the mapping of each of the input characteristics has been done with respect to membership grades of using the triangular membership function. Once this mapping will be done means that means you have converted into linguistic variable level 1, level 2, level 3. This level 1, level 2, level 3 is decided based on the input values of the input conditions, the range of the input conditions, and we decide this that some percentage of the L1 zone is interlinked with the L2 zone, because the interaction effect also may be affect the output quality characteristics. So therefore, the zone of the L1, L2, L3 will be decided so far. So like once the fuzzification is done, clustering of the data has been carried out, our mathematical model or the decision model automatically extract the number of cluster centers required for for the modeling, measuring the performance. All these NC1, NC2, NC3 are the number of different clusters, are the conditions of the input conditions for our AWJM system on machining of green composites. So these are the rules we have developed for so far, and based on these rules, this is a graphical rule. We come from the MATLAB, right? That means from the model. So what this graphical rule says that, it says that there are, you can see here, this x-axis, y-axis is a membership grades, and also contains a number of NC, that means cluster centers, and the x-axis is shows the input conditions, right? So when you vary the input conditions, so what will be the effect of my MRR, right? So one can predict MRR value at a different input conditions. That cannot be possible in our machining systems in real life, in the real conditions, right? So what we have to do, if I change the input condition to here, and one more thing I would like to hear is, I have to say is, this yellow color triangles you are seeing here, right? So yellow color triangle shows the membership grade values, okay? Membership grade values. If the AMGS, let us say X1 parameter is at, say, for example, in the range of, let us say, if it is 70. X2 parameter is, say, for example, 3.0, and X3 parameter is, say, for example, it is around 155, and X4 parameter is, say, for example, it is 4, and X5 parameter is approximately it is 126. Then what will be my MRR? So if you in the actual practice, what you need to do, we have to set again in the machine x1 is equal to this, x2 is equal to this, x3 is equal to this, x4 is equal to this, and x5 is equal to 126. Then you will measure that specimen weights after machining and before machining, and you will get a MRR rate. That means it's a tedious process. That means the production cost also will increase, manufacturing cost also will increase. So thereby, here the modeling will help you just within a second. We'll come to know that what will be the condition of x1, x2, x3, x4, x5. What will be your MRR rate? So that will be the helpful for for a designer to decide the conditions, or to decide whether my system is able to giving a exact or comparable results or not. So the variation of the input can get the variation in the output, and that decides the performance of the system. If the MRR rate or MRR value for a different variation of input conditions is coming to be or arrive to be out of the boundary, let us say if it is, what is the range is there, around 25 to 374 mm per minute, then we say that we have done a wrong in a modeling. If it is arrived within the range what we have specified so far, then we say that our modeling is exactly perfect. So then the resultant discussion. Once first we have done the optimal analysis based on the fuzzy performance grade, and then a result of the prediction that you can see here. What is basically is a different rule waivers for different each of the output condition. This is for MRR, okay, and similarly we have done for the process time as well as the surface roughness. Okay, so then next is the prediction strategy for to check the accuracy level and the error rate by the model. Okay, so that means we have done the modeling. Now I want to check whether the model is able to predict higher accuracy level or not. So for doing so, what we have done is we have inputted the same input condition of 27 experimentation in the model, and we have taken the prediction of those values. Okay, and we have seen that experimental value and predicted MRR and experimental value is having a lesser error. That means our model is able to predict a very higher accuracy in prediction of the values, or they are close to each other. Less error is found. Approximately the average error is around 1.061 for MRR case, minus 2.44 for process time case, 1.152 for in the case of surface roughness case. So one can conclude that the accuracy level of my model prediction is good. Again, move on to when we have the data, we thought to study the data because the model has been predicted, but there may be chances of the data which is obtained from a model maybe or may not be statistical significance. For doing so, we have done an ANOVA analysis for just to check whether the model data is statistically significant or not, and as well as the model which is we obtain, or the data which we obtain from the model is adequacy or not, right, or accuracy or not. However, we have already checked by plotting the predicted data and the experimental data, but further the data is statistically significant or not is checked by the ANOVA analysis. Where we all know about the ANOVA analysis, I will not explain about much on that particular aspect of ANOVA. And just quickly, I will summarize that what we have got so far by after studying the ANOVA analysis. We got the result very in acceptable conditions because the modeling p-value. We know that in our ANOVA analysis we perform. There are 4 types of tests. One is called F test. We call it a Fisher test. Probability value test, p-value test. R-square value, that is what coefficient of determination value. Adjusted coefficient of determination value. Each of the tests having its own significance of determination or its own significance of meaning as well. F test is always be performed, that is we call it the Fisher test, to know that our model is statistically significant or not. Okay, that means you can see the model here, the model. So on what basis we decide that our model is significant? Because the F value shows the higher value compared to other parameters. It's associated parameters. As such, here we got a higher value. So hence, we can say that the model is in adequacy. Okay. Second, the associated terms should be a statistical significance. For that, we go for a p test. That is, we call p probability value. We always know that we say that thumb rule that it should be 0.05 lesser. Right? This thumb rule is there. What is this thumb rule? It is nothing but it is 95% confidence interval. That's all. Right? That means your associated terms are, if it is small, value is 0. Less than 0.05, then we say that terms are more significant to the system. Right? To know the significance value or significance of those parameters on the system is judged by p-value. We also know that all the parameter like x1, x2, x3, x4, x5 doesn't have same impact on the quality characteristic. So therefore, to know that, we do for this exercise of p-value test. R-square value shows that is nothing but coefficient of determination will give you the confidence fitting of the data within the 95% confidence interval or not. So as such, it is 0.962. So hence, our data is well within the 95% of confidence interval. Adjusted R-square and there is a predicted R-square also will be there. So these two terminology will use to determine or will to clarify or justify the accuracy of the modeling. So similarly, we have done for the all the different 3 characteristics like maybe process time, metal removal, and the surface toughness, and we observe to be different input conditions and some interaction parameters as well, right? So as such, the interaction parameters we got so far is AMGS, SOD, and PWS, AMFR, NS, and grain size and the mass flow rate for the surface toughness. So with this confirmation, as we know that there are some interaction parameters are there. So whether those interaction parameters are really are present, for evidence of that or to authenticate more the ANOVA analysis, we perform the two-way parametric analysis, wherein to justify the result of the ANOVA analysis or the result obtained from the ANOVA analysis. So for different cases of the quality characteristics. So these are we call as surface plot. Sometimes we call as, because in the case of surface reference methodology, we use the terminology called as surface plots, wherein the effect of the 2 independent parameters on the dependent parameter we studied. As such, we have seen that the ANOVA analysis shows that the effect of SOD and grain size, means stand-up distance and the grain size, affects the metal removal rate. That means, obviously, as you can see here, increment of the stand-up distance, that means the abrasive water jet system is a nozzle here, and this is the workpiece. The distance between this workpiece and the nozzle we call as the stand-up distance. Okay, so this if you vary this, obviously the rate of metal removal by the system is getting varied. Okay, at what condition we may get a higher output? Here we have seen that for higher stand-up distance and higher grain size. Higher grain size means the diameter of the grains which we use for as abrasive particles is higher. Okay, so that results in, that means higher grain size and higher standard distance results a higher MRR. Yes, obviously, because from the ANOVA analysis also we've seen that the interaction of AMGS and SOD has a significant. Yes, from the surface plot we authenticate that yes, it is definitely the higher SOD and the AMGS is giving a higher. Now the question may come that if I give in some input and it is giving the output as a interaction also, but that has to be match with the physics of the process. As we all know that abrasive water system works on the principle of erosion, right? So when you increase the standard distance, what will happen? And increase the grain size. Yes, SOD is also increasing and the grain size is also increasing. What will happen? The abrasive particles, okay, if you increase, what will happen is the kinetic energy will get may get reduced, but it covers a more amount of space on the workpiece, and the bombarding of these particles covers the larger area of the materials with a higher standard distance, so results in removing of the material will be more. But there is a drawback also will be there. What drawback? There may be chances of RA value will be less or higher. But in the meantime, what we need to get, RA should be very lesser. Okay. So therefore, optimum value is very much essential. It means optimal condition at what level of SOD, at what level of grain size, at what level of nozzle speed is optimum to get a MRR, simultaneously RA, simultaneously PT is very much essential. But this, what I'm trying to say here is this surface plot is only used first to study the effect of the individual, individual parameter or dependent parameter on the independent parameter on the dependent parameter. So further we have moved on to the residual analysis we have performed. That is basically to fitting the model data, whether that model data is normally probability or not. Okay, normal probability test we have performed. So for that we have done is we have plotted the residuals of the values of the model data, and we have seen that all these data, okay, what we fitted into the normal probability plot shows the normal distribution, and normality will be valid because all this data is closer to the straight line. Okay, this closer to the straight line, so that one can confirm that a mathematical model which what we have developed so far, so it is well behaved with the normality. There is a confirmatory analysis also we have performed for different conditions of input, and we have plotted that experimental quality characteristics with respect to the predicted quality characteristics, and we have seen that there is a good agreement between the input condition and the predicted data and the experimental data. Various types of confirmatory test of the model has been carried out. First is accuracy analysis, and the test. First accuracy test we have performed for the model. What I am discussing is for the model, not the experimental conditions. So for this, we have determined the percentage error between the error of experimental MRR and the predicted MRR, and we have seen that very lesser error we obtain between the MRR prediction MRR, that is by the model, experimental MRR, that is by the experimentation. The second test we performed is performance analysis of the model with the artificially generated data. So there may be questions may arises that yes, sir, you have done the what is called as some modeling, and we have the input data and we have fitted into that input data. And anyway, as I already told that there is a black box. Whatever you give, the output will come. Whether your model is able to predict for in-between values, this question can be rectified. That can be solved by using another test is called as artificially generated data. Artificial generated data is the process of generation of the data that is in between values of the range. So that means the input condition I am varied. Okay, so these input conditions I don't have any experimental data for this. Now whether your model is able to predict the performance characteristics up to the mark, That we have checked by using one test is called as artificial generated data. This data we have generated so far for study, we have generated only 15 conditions. That is artificially generated data, and that data is again inputted to our system, our modeling system, model system, and then we have extracted the experimental MRR and the predicted MRR, and we have seen that very lesser deviation we found. That means we have checked the deviation between experimental value and the predicted value. Then we found that very lesser deviation. That means in our model is sufficient to predict under different condition of the data as well. Right? That means artificial data also our model is able to predict. So hence, so deviation as such, the deviation is very seems to be very lesser. So our predicted model or the model is able to predict very what is called as the lesser deviation, and hence it is comparable with the experimental results. Now here the experimental result we extracted. This can be extracted by two ways. One, each setting you will be setting into the machine, extract the MRR value, or else one we have used here the multi-regression concept. The similar condition of the experimental condition we have used, and we have predicted these equations of the experimental. Again, these conditions of the artificial is inserted into these equations, and we have gathered the experimental values of the quality characteristics. Then we have predicted by using mathematical model whatever we have expert system, that is a Taguchi integrated with the fuzzy logic expert system, that is specifically Sugono based subtractive clustering based Takagi Sugono model will predict the quality characteristics, maybe MRR, process time, and the surface roughness. So the deviation has seemed to be very less. So hence it is we can say that our model is able to predict a very comparable results. There is another test also we perform to say that our model is very efficient. That is what performance analysis with ANOVA. I think whatever the I'm showing, I think none of the authors have been carried out in this way to test our model in a various ways of testing to confirm our model to be satisfactory model or accuracy of the model of the prediction. Because why this is necessary? Because any model, as I already told, that it is a black box. Whatever you give, it will give some output, but that output, interpretation of that output is very important. So therefore, that interpretation of the data and the output quality characteristics obtained by the model to be judged by various ways. So as such, what we have shown for two tests, another test is the ANOVA test. So here what I have done is, what is the concept behind of doing this test is, so we have the two results, one is the experimental results and the predicted results. So similar conditions we have predicted, and we have statistically studied the ANOVA for a different predicted data and the experimental data. So experimental data, R-square value and R-square adjusted values we have gathered, and we have seen that for predicted model, predicted data or the data predicted by the model shows higher value of R-square value. In case you see, for example, MRR 0.962, whereas experimental MRR 0.915. Similarly, for surface roughness 0.997, but experimental 0.942. So now one can see here the how accuracy a model is, but the another aspects of this may also arises is that how come based on this R-square value will says that the accuracy of the model, or what will be the reason behind that the experimental value shows a lesser R-square value? Because the experimental we are doing in the real conditions, there are some of noise, okay, or some machining condition may affect, or there are some called as assignable causes causes or chance causes also. Okay, all these matters in experimental condition and affects on the quality characteristics. Obviously, yes, because sometimes we don't know the noise presence in the system results in error in the output quality characteristic or variation in the output quality characteristics. Machining condition, some machining conditions used in thermal systems, machining conditions use some mm, other conditions. Okay, then assignable causes, chance causes, sudden breakdown, sudden vibration. All these conditions may result in a lower value of R square value. So that is justified here in our results. Yes, experimental value of the quality characteristic of the system shows a bit lower R square values. That signifies that the lesser statistical significance compared to the predicted data by the model. There is no as such the conditions of the error are assignable causes, but there is a risk in the modeling as well. If you do the error in the modeling or in the stage of mapping or maybe generation of the if-then rule, so therefore a care must be taken while generating the rules and while mapping. And appropriate method of selection of the fuzzification and defuzzification also plays very important role in getting the higher accuracy values, because one can use various fuzzification method, various defuzzification method, and one can use different subtractive clustering techniques. One can use the Mamdani method. Again, I can say that variation in the input condition of the model also will result in variation in the output quality characteristics. So therefore, somewhere other way in experimental condition as well as in the modeling condition, we have the demerits. So that means that those demerits can be minimized or resolved by using suitable appropriate methods. As such, in our condition of the model, we have got a higher R square value to get a higher accuracy of the modeling. Similarly, we have studied that whether the surface plot is of the interaction study of the parameters is having the similar trend or not. So for that, we have plotted two x-axis and y-axis, keeping other parameter into constant, and we have seen the behavior of the trend of the input condition is similar in case of in our study also. So hence this is also one confirmation that the mapping of the input conditions for the study has been done properly. That is another test we call the surface plots test for saying the accuracy of the modeling of our study, right? The next move on to the for a different output quality characteristics also we have done, and we have seen that the behavior of the surface plot seems to be similar in mapping, or effective mapping of the input condition have been made by the designer who is developing the model for a AWGM process. So this similarly for a response surface, that is what we call as a RA value, that means surface roughness value, wherein the similar trend we obtained in the case of the different effect of the different parameters. So the final test, that is what it is, a test number 5, that is a confirmatory test. So this confirmatory test one can avoid also. It doesn't mandatory that it is to be performed, but it is to be performed when your optimal conditions is out of the box or out of the matrix. As such, we got the optimal conditions within the matrix. Then it was not necessary. But what we have seen that whether our system is further will give us same result or not. For that, we have done the confirmatory test. So the optimum condition is grain size is 100 mesh we have taken, and 3.5 stand-up distance. Pressure is 225 megapascal, and feed rate is around 3 gram per second, and nozzle speed is 125 mm per minute. For this optimum condition, further we have set it into the machining conditions or in the machine, and initial experimental value is this. These are your initial experimental value and confirmatory experimental value. Okay, and next is the predicted value by the model. As you can see here, there is a variation in the exist in the data, right? Initially it is around 311.12 mmq per minute, but after doing confirmatory experimentation, it is around 309.1 mmq per minute. But if you see the modeling 312.56, it is a higher side greater accuracy, whereas it is the lower side is reduced. So now the questions come in our mind is that what is the reason behind that of reduction in this? There may be chances of noise is the one condition. The system, when we are performing the setting, there may be something called as noise or uncontrollable factor. The second is assignable causes. Okay, it may be the another reason. Third reason is chance causes, and the fourth reason is environment condition. All these makes variation in the data. So for that variation only we perform various types of statistical methods to study the statistical significance or not, because variation maybe is there. Okay, variation is do exist in the nature. Whatever you may be the skill of the operator, whatever may be the higher end technology of the machining system, and whatever may be the high quality of the what is called material we use, definitely there will be variation is there. If one can, if you can see here only experimental initially we obtained 301 and confirmatory for the same condition we obtained 309. That means a variation is do exist in the experimentation. So all this because of the many reasons, and that need to be handled by using a statistical techniques. Other researchers already, many people have already worked on this, and many papers also available in the literature that considering these conditions into account. Sometimes we use the control charts also, wherein to study the process of the system. Okay, whether the process is controllable or non-controllable, depending upon the conditions of the input conditions. If the system it shows that initial itself it is uncontrollable with the upper limit and the lower limit, upper control limit and lower control limit, in that case that parameter will be removed and further the remaining parameter will be considered for the study. So such conditions, such type of study also we do before deciding the input conditions, or before deciding the performance of the performance of the process. So as such, the variation is we obtained from the confirmatory experimentation, but that deviation we have calculated, we can see the deviation is comparable. It is not having much deviation, and we know that there is a thumb rule we always implement in our any comparison or validation purpose. That is what is called to 5 to 8% if it is variation is there, that can be acceptable. That variation may be due to these all reasons. Okay, as such in our case study also we see that there is a lesser deviation, and which is fall within the lesser of 5% of zone. So hence the result is comparable and acceptable with the experimental results. So come to a conclusion. The participants, whatever I shown the case study, it is just our aim is to developing one integrated method of which is based on statistical method as well as the expert system, and that implementation of that method, whatever we have developed so far, a new strategy or new decision making strategy, we have to validate that. We want to validate that new strategy of decision making. For that, we have considered an experimental case study. That is nothing but it is machining of green composite under AWGM machining conditions, and we have seen that greater and acceptable results we obtained from system Okay, so that means we obtained very optimum conditions, and we obtain ANOVA analysis results also very acceptable conditions, and also confirmatory and performance analysis of this system shows a higher accuracy level. So therefore, the kind of predictions we obtain from our model for this limited to AWGM process study seems to be good and comparable. But again, I'm saying that it may differ for the other systems also, isn't it? So how can I say that it definitely give the similar results to the photochemical machining process or electric discharge machining process and so on, because the condition to condition may be differ. There is a non-linearity in that. So until when we model perfectly to those systems, so one cannot say that our decision model will definitely give based on the modeling and based on the conditions. It may maybe results. So finally, so develop model and is a systematic approach for prediction and optimization in our one application. So hence this be used for for GM applications. So there is a important call. Let me take one call. Sorry. There was an important call from the college. Yeah. So next is the future directions. What one can think in this particular direction that can work in this particular optimization area. That is development of new optimization technique is another area where one can think of to work in this area of soft computing. And there are implementation of some other soft computing techniques for experimental data analysis and modeling purpose of the manufacturing systems. And another area, one of the is a hybrid optimization technique. So that is the one area most of the researchers have not touched, but some of them are already started up working in the hybrid optimization techniques. And there is one more optimization technique or decision-making tool, that is a multi-criteria decision-making techniques. And that multi-criteria decision-making techniques are like AHP, Mura, Promethi, Akra, Promethi 2, Musra, Topsys. We all know that all these techniques can also used for valuable decision in manufacturing systems. Very less effort made by the authors in the area of the MCDM technique and its implementation in the manufacturing areas. The last one more area what I found is the nature optimization models. That is obviously many people are working, but in this direction I am also working. One of my PhD scholar is working in this particular nature optimization technique and developing a new optimization model based on the nature. Like already there are plenty of nature optimization techniques are there, like spider optimization and colony based optimization technique, or honey beams optimization technique, all this kind of thing. So there are still possibility of optimization techniques, so one can develop using natures, and that optimization technique can be utilized for our manufacturing areas as well. So thank you, and thank you for being patience for listening my lecture. And this is my contact details. One can contact me anytime if you need any help regarding the manufacturing systems. So from my end is over. Now I will over to Hemantji. Is there any queries from the participants? Let me take one or two questions from them.
Yes, sir, sure. Thank you, sir. On behalf of Department of Mechanical Engineering and all the participants over here, I thank you very much, sir, for your insightful presentation on application of soft computing techniques for manufacturing systems. Sir, your talk was particularly appropriate at this time when we are considering new initiatives for expanding ourselves into multidisciplinary areas. Now, we would like to hear from participants. If you have any queries or questions, kindly please ask by unmuting yourself.
Jagdish sir,
Yes, sir. Please.
so we are really grateful to you, sir, because you have taken a time to prepare and spend your valuable time with us. My question is, which optimizations and artificial intelligence techniques are more effective in intelligent transportation system applications?
Yeah, sir. Thank you for very valuable question, sir. It is as this question is having uncertainty. The answer will also be having the uncertainty because there are plenty of optimization techniques we came across. All these optimization techniques have its own merits and demerits. Depending upon the type of the application and the need of the application from the applications, so one can select a particular or appropriate technique. Yes, of course, there is a variation in we exist as because real conditions also, as we have seen that the real conditions also having some variation. That is nature by nature. Similarly, in our optimization techniques also having a variation. As such, we know that these all optimization techniques are approximation techniques. That's why we call it approximation results we get. So therefore, depending upon the type of the application only, we have to choose and the need of the applications. That is the only thumb rule we always follow in the optimization area for selection of a particular technique.
Thank you, sir. Thank you.
Yes, other participants can also ask if there is any questions.
I'm expecting more question. I was expecting more question, but here there is no much questions I'm getting.
Yes, dear participants, you can ask if you have any questions. Sir, I would like to mention here that your presentation was so lucid and simple that all of us can easily make out, sir.
Okay.
So only when it comes to application part, they will have some queries, and I'm sure that since you have already shared your contact details, they will definitely contact you with respect to that, sir.
Yeah,
Uh,
definitely. You are
yes,
most welcome for that.
yes, dear participant.
Sir, here is a one small question.
Yes,
Yes,
sir.
sir.
Please go
Very nice
ahead.
presentation, sir.
Thank you, sir. First of all.
Very informative session. I would like to ask, are there any commercial softwares which deals with this kind of expert systems? Like we know Minitab and SPSS and other things, okay, which are there for the optimizing or analyzing the topology data and other things using topology and other experimental data. Like this, do you have any commercial software available for this thing, expert systems?
Yeah, we have, sir. First of all,
Okay.
very thank you for valuable question. So we have already the MATLAB. It's a well-known software wherein we can perform all this kind of fuzzy
Okay.
logic kind of activity like soft computing techniques, neural network, and deep model. And all. There is a well-known software. So one can either use the modules which is available in the MATLAB, or else you can create own code for developing so far. So as such, we have done the modification in the model. We have not used the existing model which is available in the MATLAB. We have modified the things like what we have done modified, subtractive clustering we have added into account. Normalization step we have added into account. So those kind of modification we have done. And after modification also we have seen that very higher accuracy level of the prediction. So we have developed our own code and we have predicted the things.
Okay, sir. Thank you.
Hemanji, you are unmute actually.
Yes, sir.
Hemant, you can conclude. Please.
Yes, participants, as you all know that a recorded version of this session will be available for your reference. Kindly do refer it. And now I would like to thank once again to our honorable speaker, Jagdish sir, and we would like to have your consent to speak to us again in near future. Many thanks from all of us for you, sir, for spending your valuable time as well as for sharing your rich experience in optimization of manufacturing systems. Thank you so much, sir.
Thank you so much to you as well and your organizing team members as well as the entire institution for allowing me to share my experiences to the participants. And I do hope that definitely in near future I may get a few more opportunity to share my knowledge not only in the field of application of the optimization area. I'm working in the other areas as well, like development of composites for additive manufacturing systems and surface structuring and all. So in future, if my service is needed, definitely I will be. You are most welcome. To contact me. Thank you once again to all the participants as well as the entire team. Thank you.
Definitely, sir. We look forward for your valuable suggestions in all our future endeavors. Since we are going for autonomous, we would like to have your association continuously, sir. Thank you so much.
Okay, thank you.
Thank you, dear participants, for your valuable time for the first session. And we will be shortly having our second session at 11:45. Kindly do join. After a short session, we will be having or concluding the FDP with valedictory function. So we request all of your presence over there. Thank you. Thank you,
sir.
everyone.
So, Hemanji, can I leave now?
Yes, sir. Thank you so much, sir.
Okay.